Next, I'm very excited to introduce Margaret McKenna, the Director of Data Engineering at Devoted Health. She comes to data from engineering, but she has led, hired, and worked alongside data scientists across the skill set spectrum. She started the data team at Runkeeper, led engineering for the data science platform team at the Broad Institute, and now leads platforms engineering at Devoted Health, which includes data engineering and partnering very closely with data scientists to enable them to move faster and do more amazing work. Thank you, Margaret.
Thanks, Heather. This is a very cool gathering to have all these data science and data science affiliated people, so thanks for having me. As Heather said, my background is in software engineering, but I've been around data and working with data for a pretty long time at this point. Early on in my career, I worked at a company that built recommendation engines for retailers and entertainment companies and advertisers. Blockbuster Online was one of our customers, so that gives you a sense of the era. And then sort of went from there, built data teams. Currently at Devoted Health, I lead a few engineering teams, one of which is platforms engineering, and included in that is data engineering and infrastructure. We're fortunate at Devoted to have DJ Patil as our head of technology. And as a result, we have a very high-powered data science team. So one of my personal goals is to keep them super happy. I don't think I've quite succeeded yet, but we're just getting started. So today I want to talk about how basically to leverage engineering and data engineering to make data science faster. So, does this work? There we go. Okay, so for the purpose of this conversation, I mean, we've already heard a little bit about how data science is lots of things and it's used in lots of different places. I want to ground this conversation pretty particularly in data science in business. My background is predominantly in consumer technology, though I was at the Broad Institute as well, so a little bit in research. But I want to just sort of focus on data science as improving the quality and utility of a product or process. So this is the imagined life of a data scientist at a company. You are at your computer and you control all the computers, hundreds and thousands. And everything you do is affecting all the users of your application. And as soon as they do something, you learn about it and your algorithms improve and life is incredible. In my experience across a bunch of organizations, this is more like what being a data scientist is like. So you're on your computer with some cool data and you're thinking really awesome thoughts about how to change the world. But it's kind of, in a lot of cases, stays right here. So many data scientists live in a world like this. And not all, and we heard a little bit earlier today about some organizations that are kind of shifting away from this, and certainly places that are more mature in their evolution are much farther down the path on this. But as I've seen this again and again in startups and even larger organizations. So they often sit apart from product and engineering and operate on different schedules with different business inputs and different technologies. So like you may even have different stakeholders that are kind of suggesting what data science works on versus product or engineering. They often do their analysis on their own computer or maybe manually deployed cloud resources, but in either case, things that can't be easily shared or replicated. And then, I think this is a well-known fact, they spend a lot of time getting data into a shape that's useful for analysis. So I think there's some like stat about 80% of data science is cleaning data or something like that, but it's sort of true. And in a lot of cases, there's no clearly defined path for turning a useful insight into something that informs and learns from user behavior. I think I heard a comment earlier about you've developed this insight, but how do you then get it out to your business owners, out to your users? So when I'm thinking about scaling data scientists, I'm talking about speeding up the time that it takes to get to developing that insight, and then speeding up the time that it takes from developing the insight to affecting your product or process with it. So in the case of speeding up time to insight, and again, this is grounded in consumer technology, so we're talking about probably structured or semi-structured data, but it's really important to have a data warehouse that unifies data from all your sources. So whether it's your production database, click feeds, click streams, data from your email provider, whatever it is, you want to kind of get it all in one place so you're not doing that collation yourself. Supporting that is you need a really good ETL process that cleans and denormalizes the data. So we know what cleaning is. Denormalizing, many of you will know, but in case you don't, it's taking the data that is basically structured to support web application work and turning it into wide tables where all the interesting variables that you want are in one place. You also want this ETL to run frequently, so you want to be working on fresh data. You don't want to be working on data that you pulled down like 2 weeks ago or a month ago. And you want retry and alert failure capabilities. So like a theme that I want to talk about throughout this is getting computers to do work for you. It's not a great scenario when you're working on your data and you are like, this doesn't seem quite right. And you ask the person, oh, did that job run? And then sign in, they like SSH into some machine. Oh no, it stopped running last week. Like, you don't want that. You also want resource management that's abstracted away from data scientists. So I'm an engineer and I don't like spinning up Spark clusters on my own and figuring out how to SSH into them and get the logs and all this. Like, that's not high quality use of time for data science. So you want to basically create tools that abstract all of that away. And then on the same note, you want resources at scale. So if something takes you 6 hours to run on your personal computer, that's not a great use of either your computer or yourself. So like, you want to basically be developing infrastructure that makes it easy to run your jobs on something that's going to make them run much faster. So that's the getting to the insight. So we've got our data available, it's fresh, it's in a place where you can run like complex analysis on it pretty quickly, but then getting that insight into affecting a process or product, they're the following capabilities that we kind of want. So you want to write analysis that's under source control, peer-reviewed, testable, and capable of running in any environment. And the reason you want that is because you want to get very quickly from your analysis to putting that in production. So having it under source control, something like GitHub, where, I mean, I also had this experience both in engineering and data work where I made an innocuous change to something and then made another change and forgot about my innocuous change and ran the thing. And I was like, why is it broken? Oh, that innocuous change. Having it under source control and with reviews on every PR that merges really helps protect against that and be sure that you know what you're running at any time. Having testable code means that you've deployed something to production and you're pretty sure that the algorithm does the thing you think it's going to do. You haven't made any changes to that. And it's capable of running in any environment. That's, again, like you want it to run on your computer and your colleague's computer so they can reproduce what you're doing, and your staging environment and your production environment. You also want the ability to schedule your analysis to run at regular intervals with the same robust operations as a production environment. So this is similar to the ETL stuff, but starting to think about your data work as production ready, like production worthy. So again, like get computers to tell you if your job is getting slower over time. If it broke unexpectedly, have the computer try again if it's just a network failure. Like these are all places where data scientists or folks working with data scientists can end up spending a lot of calories in not high value activities. And then finally, we want the ability to deploy production APIs written by data science. So this is also a thing I've seen a lot. Data scientist writes a model in Stata, maybe, R, Python, but your application code is in Java or Objective-C, Go, and so there's a period of sitting next to a software engineer for a long time, trying to translate from one to the other and maybe not quite getting it right. I think in a forward-looking way, we want to think about how we actually can take the data science code and deploy it as its own service that can answer questions and kind of cut the software engineers out of it. No offense to software engineers. So this is a way that this can look. There's lots of ways that you can kind of introduce these scaling capabilities, but this is a pretty simple one. So we have our data scientist here checking code into GitHub. Once it's checked into GitHub, we're doing CI/CD. So I don't know if people are familiar with this, continuous integration and continuous deployment. So continuous integration means as the code is about to get merged, I run a bunch of tests against it. I'm like, great, this code is mergeable. And then when it's done, I can deploy it automatically. Maybe to my machine learning microservice, also to a job scheduler. So Say you have a dashboard that your executive team looks at every morning. You want to make a change to it, it can go through this pipeline and automatically get updated. The job schedule also should be taking care of any external data, pulling it back to the data warehouse, updating roll-up tables, et cetera, and then once again, you're back to your data warehouse with all your data sort of easily accessible. So how do you start doing this? Some people will already be down this path. Among other things in my background, I started a company at one point, and I was the only developer. And I took some of the things that I've learned along the way and was actually able to do this with very little resource. So I want to basically frame this to say you don't need a giant data and infrastructure team to make this happen. There's a bunch of off-the-shelf tools to get started. So, however, if you do have teammates, it's really important to make friends. So we just heard from Jennifer, one of our data scientists at Devoted. She's talking to Carla, who leads our data engineering team. This collaboration is super important, both for the data scientists to start to understand data engineering practices around scaling and performance and all of that, and also for the data engineers to understand, Jennifer's looking at me like she wants to kill me, and for the data engineers to understand the problems that the data scientists are trying to solve. Another little acronym I put up here is SRE, so that's Site Reliability Engineering. This gets into the operational parts of this. You really want that team to also be a partner in what you're doing, because this is like, how do you end up getting all the machines to do all your work for you and not just humans? So once you have friends, the second thing you want to think about is starting to write your analysis like an engineer. We use this phrase "go-hio" a lot at Devoted. It comes from Amazon. It's get our house in order. It's basically start cleaning things up as if somebody is going to take the thing on your computer and do something with it and contribute to it or deploy it. So again, I'm sort of repeating some of these things, but it's really important to commit your code to source control. I've definitely seen code emailed around. I've seen it shared via Dropbox. It's really hard to keep track of what you're doing that way. And the other thing is write code that is modular, meaning like breaking down your code into individual components that then can be tested, that don't have a bunch of complex logic in each step. And finally, performant, and this is where it's helpful to have your data engineering friends. You won't necessarily have the experience to know what it's like to run your model on many millions or billions of rows of data. Your data engineering friend is going to help you with this, but it's good to start thinking about, like, this isn't going to run on the sample that I pulled down to my computer. This is going to run out in production, which has much different requirements around performance. It may also run against a data warehouse where there are lots of other data scientists trying to do great work, and you don't want contention there, so important to start thinking about. And then finally, this is a thing you can start doing without a data engineer, though I'm sure they're happy to help you, is to start creating those reusable roll-up tables. So instead of having the beginning of your analysis like a whole bunch of work that gets your users or your the products that you want to analyze, instead of all that work sort of at the beginning of all your analysis, like have a job that runs that and creates your table, and you sort of start from this like really nice, clean table. So after that, you want to think about building data infrastructure. And these are sort of the important elements, I think. Data warehouse we talked, I'm not going to really touch on particular technologies too much, but if you have questions, I'm happy to go into them. There's a bunch of, whether you're on cloud providers or otherwise, a bunch of utilities for any of these things. But certainly data warehouse is great. Job scheduler is really important, one that you treat like a production system, so like not cron as an example. Observability means like I'm monitoring this thing. I can tell how the characteristics are changing. So is my data warehouse getting really big and all queries are slowing down? Are jobs failing? All of that kind of thing. And then we talked about continuous integration and continuous deployment. And again, I want to re-emphasize, like, this could be a very sophisticated setup that has a team of engineers and site reliability people working on it. Or it could be something that a person spent a week or two setting up. There's like totally, in 2019, possible to do this relatively cheaply. So finally, we hope we have a lazy data scientist. So I don't know if anyone here is familiar with the lazy programmer trope, but it's basically the programmer who really doesn't like to toil and so is automating everything in their path and kind of reducing all the like low value work and really focusing on what's like super interesting and unique that you can be doing in your analysis. Google has this always be cutting toil from their site reliability engineering group. It's the same kind of thing. Like, you'll be happier, you'll get to better insights faster if you do that. And with that, I will open up for questions.
Thank you so much. Oh, is this working? Oh, it's great. Thank you so much. This was super helpful. I'm currently a data scientist working at a sort of a smaller company, and we have a lot of these issues. One thing I'm wondering if you could talk more about is how you monitor and keep track of data quality issues in your pipeline.
Mm-hmm. That is a really excellent question and not a solved problem. But I do think that there's a couple things that are important. So one, doing the testing of your code, so unit testing of your code. And the other is the ability to have some kind of snapshot or something of production data that you can run your models and tests against. And this is I'm gonna like call out to Snowflake here, Jennifer. So Snowflake is a data warehouse that I've used in the past, and we're moving to it at Devoted. And it basically makes it super easy to take a snapshot of your production data warehouse, spin it up for a short period of time, run tests against it with real data, and tear it down.
Hi, I have a question about the pragmatic capabilities. So, like, you work for a company that's huge, and as much as you want all your data scientists and engineers in one place, they're all over the place. Half of them are working from home in slippers. The marketing people have one pathway, and the customer service people, the product data scientist people all come in from a different way. And you're trying to work towards this level of continuous development integration. Like, what do you see as the path that you, as that solo artist working on your own in an isolated environment, can take to making that integration? Is it containerizing things, or like, how can we make things that are deployable and usable when the rest of the team doesn't even know we exist or doesn't care?
Totally. It's a really good question, and I think applies to data science and all other technology work everywhere. Is like, how do you get an organization to shift gears and do things a different way? I think it depends a little bit on your organization and how willing they are to let you experiment with different technologies. I think that even before, certainly containerization is super valuable for running things everywhere in production and job pipelines, all of that. I don't think it's required, though, to get started. So I think if you have the capability to sign up for something like Circle CI, which is a CI/CD tool, and just start connecting your GitHub repository to that thing, you will start to get some of these patterns of behavior. We use Airflow at Devoted, which we did stand up ourselves, so that may not be the best example if you're looking to just get started with a SaaS product, but I'm sure there are other ones that you could use. It is, again, this goes back to the culture of the organization, but if you're able to sign up for SaaS tools, there's a bunch that make it pretty easy to get started with some of this. And in my experience of making changes like this, once you show people that things can be way easier, they're really happy to adopt. Like, suddenly everybody wants to be in on this thing.
Question over here. Okay. Yeah, thanks for the talk. A lot of it really resonated with me because I'm a data scientist at a startup who has to do a lot of these tasks that you mentioned and don't want to be doing a lot of these tasks that you mentioned. So the issue though is that we have kind of a team of software engineers, and they're available sort of if I have a problem or a question that I don't know how to solve, I can sort of ask them one-off questions and they'll oblige. But we don't have a sort of a dedicated data engineer. And so do you have any advice on sort of how to advocate for this problem? Because a lot of these pain points are felt by data science and not necessarily by other members of the company. So any advice on that would be great.
Steal a software engineer. Yeah, so I think that if your company has decided that data science is valuable to their business, then data engineering should be an obvious move. Like, it will make your data science team faster. It will mean that the insights are going into some kind of production or process faster. And also, I will say that, like, sort of joking about stealing a software engineer, the skill overlap is not totally one-to-one. There's like particular skill sets in data engineering that are you won't find with a lot of software engineers. So I think you would actually want to hire particularly for that role. And actually, do you have a like a DevOps or SRE team? Okay. Well, then that will add that characteristic to your data engineering job rec. But yeah. And it's not a super satisfying answer, but I think if you go to the people that decided to hire data scientists, like, they should be compelled, I think, to also hire your partner in data engineering. All right, thanks.